Very good. I guess it's time.
It is time to go. Yep.
Yeah. Yeah. Hello, my name is Jang-woo Ryu. I'm Professor of Information Sciences and Technology here at Penn State Altoona, located in central Pennsylvania. Our college is one of Penn State's 24 campuses across Pennsylvania. My expertise include data science, cybersecurity, and software engineering. I'm currently working on a collaborative machine learning project with VSoft. So today I'll start by providing you with some background information on artificial intelligence, also called AI, especially machine learning. Next, my talk will cover how machine learning is relevant to manufacturing. And finally, we'll share my own experience with helping the manufacturing industry by leveraging machine learning. So if you were expecting my presentation to be about AI taking over the world, you are at the wrong place. You'll be disappointed. So what is AI? Artificial intelligence, or AI, refers to a system's ability to simulate or mimic human mental power. And AI is rapidly gaining its popularity. AI started in computer science, but it's broadening its reach into other disciplines and into industries, including manufacturing these days. So then what is machine learning? Machine learning is, I would say, a subset of AI, and you can think of machine learning as a self-learning and self-enhancing algorithm. To make machine learning possible, data and data modeling, as the previous speaker mentioned, are necessary because machine learning algorithms learn through data. Our manufacturing industries have gone through multiple phases, starting with mechanization at the stage of Industry 1.0, and Industry 2.0 was driven by mass production and electricity. Automation was the hallmark of Industry 3.0. The latest buzzword in manufacturing is Industry 4.0, also known as the fourth industrial revolution, which features ubiquitous smart systems working together through the internet with minimal human intervention. So Industry 4.0 takes Industry 3.0 to the next level by incorporating, I would say, new technologies such as Internet of Things. I'm sure you're all very well aware of IoT and AI. And self-monitoring is another important characteristic of Industry 4.0. So here at Penn State Altoona, we have a unique engineering program called Electromechanical Engineering Technology, or EMET program. As its name suggests, our EMET program has a balance of both electrical and mechanical curricula and is in high demand in manufacturing and other related industries. Bruce Mueller, who is one of our engineering faculty members, met a VSoft representative at an AI Innovation Consortium conference last year and started having conversations on possible collaborations. So the first step in our collaborative efforts was to identify and define a manufacturing problem to solve. We finally settled on a scenario in which our goal is to detect defects in pipe threading. In a typical manufacturing scenario, a human operator will inspect hundreds of pipes for glitches, which is time consuming, expensive, and also very error prone. Therefore, an ideal solution is, I would say, automation, which is not simple in this case because it requires vision capabilities and decision making based on AI. And in my opinion, a problem provides a perfect testing ground to push the limits of the industry 4.0 technologies. Our EMET program alone didn't have all the expertise required and the manpower, especially in the area of machine learning. Luckily, our college has an information sciences and technology, or IST program. And this is how I got involved in our project as a professor of IST at Penn Altoona. In our project, I also saw an opportunity to expose our students to a real life machine learning problem. And I'm sure that students will benefit tremendously from learning the software tools used in this project and gaining problem solving skills. Also, machine learning applications in IT are growing, and this experience will give our students a competitive edge when looking for job opportunities. One important lesson I learned here is that you need an interdisciplinary team to run a successful AI project, as demonstrated in our case. So in our case, a VSOP team, with the help of Kians, provided a camera setup in terms of our hardware implementation. And our engineering team has been in charge of building a contraption to hold the pipes in the most optimal positions for image captures. The camera, in this case, will take photos and send them to a cloud system for processing. Our AI team is using an Amazon AWS cloud computing environment. In particular, we're using Amazon SageMaker, built on S3 and Docker, to build and train our model. Ground Truth is a data labeling extension of SageMaker, and our focus right now is finishing an accurate training data set for the pipe threading defect detection machine learning project we're currently working on. So COVID-19, of course, has been a big factor since we lost physical access to our lab facilities at Penn Altoona due to the virus. However, we persevered, continued on, and found an alternate site to do the scanning. Our AI work is free from disruptions as long as we have the necessary data. But the data, I guess in this case, the image capture was a challenge. But we also had to train our students to be able to use the AWS platform and the AI software. So once our proof of concept project is over, we want to broaden our scope in our future directions in the related areas of manufacturing. In summary, I covered AI and machine learning, the implications and roles in manufacturing. I mean, their implications and roles in manufacturing, and we also got a glimpse of what's possible through AI in manufacturing. And we're still at an early stage in our project in this case, and we really hope to report back with more success stories next time I see you. And that concludes my presentation.
All right. Well, thank you so much. We did have a couple of questions come in, so I'll go ahead and ask you those. The first one, how exactly is AI teachable in reference to defect detection?
So I guess, earlier I talked about labeling, and we have to develop this training data set first. So that requires a lot of human intervention, because you actually have to tell what images actually include defects. And based on all the labeling work, the machine learning algorithm is able to train itself, and eventually will be able to detect a defect. But it involves a lot of labeling work by manually inspecting, I guess, these images and telling the machine that, these are the pipe threads with defects. So the training is really critical.
All right. And the last question here, what results in ROI can be expected when implementing computer vision-based defect detection, such as the pipe solution you talked about?
Mm-hmm. Yeah, I think the return of investment is really, I guess, associated with automation. And this way, I think you can really direct your resources to places where you can, use your employees more effectively, instead of just looking at this thing whole day, just trying to find any kind of defects. So it really minimizes the manual labor aspect of the work, and then actually increases, I guess, the effectiveness of how you use your manpower, the employees, and just like in any industries in this case.
All right, and then actually one more popped in. So
Okay.
any advice on how I can align with my local university to build AI collaboration and innovation?
So in our case, I mean, if you're, for example, near our college, we actually have a mechanism. It's called the Innovation Factory, and we make it really official to work with the industry out there. And I mean, I guess you don't really have to be local for you to be able to work with us. And since the process is very well established already, you can actually fill out this form online and then start working on, the project of your choice. But of course, I mean, there is a vetting process where we have to be like on the same page in terms of whether the project is what students are interested in and so on. But that's just one example in our case, but I'm sure there are a lot of other universities out there doing similar things, just like what we're doing in our innovation factory. But you're welcome to contact me, and my contact information, I think, is available here. And you could work with us, or you could, of course, work with other universities out there. But I mean, there are a lot of these opportunities. And I think one thing I want to mention here is that it's like very mutually beneficial to be able to work together, because in my case, I train my students, and I also get to work on a real life AI machine learning project. And from the perspective of industry, of course, they get their work done. So it's sort of a win-win kind of situation.
All right, and if you wanted to answer just the one more that came
Okay.
in, where do you see, in your opinion, where do you see manufacturing with AI in 5 years?
Yeah, I think in 5 years, I mean, 5 years, I mean, you can say it is a long time, or depending on your perspective, it is such a short time. But I think there will be a lot of proof of concept projects actually getting done in the next 5 years. And hopefully we have more, artificial intelligence and machine learning embedded into what we're doing in, manufacturing, because I still see a lot of these places where they really depend on human labor for these repetitive works. And I'm hoping that at least a fraction of what's happening can be replaced by something like machine learning and free these people from very repetitive work and let them focus on other more productive areas of their work.
All right. Well, I think that's all we have. Nothing more popped in. So
Thank you so much.
So thank you so much for taking the time. Like he mentioned, his contact information is right here. And if you think of anything else, please feel free to reach out to him or the email at the very end of the presentation if you want to get anybody's contact information. And that, I think, is all we have for him. So thank you, Jungwoo, for joining us.